Demo of CloudMorph AI. So CloudMorph AI is a AI-powered cloud optimization report generator. So what happens is when generally organization provision resources or infrastructure for their applications, generally they can't get the proper estimation for the size of resources or systems they need to provision. So they generally tend to either the systems either tend to be underutilized or they tend to be overutilized. So in that scenario, what CloudMorph AI does is we can provide it with the logs. For example, it provides us with two type of options: ECC systems, which are a cloud-based elastic compute cloud system. So for ECC systems, we will need to provide two CSVs to it, one with the cost CSV, which will have the cost related data for the computing systems provision for the infrastructure, and second is usage CSV. So it will have logs from different timestamp for different systems in order to gain the data. And the second type of option it provides is for legacy systems. For legacy systems, we will only need to provide usage CSV, because for legacy systems we don't have any sort of costing like we have for the cloud system. So let's first get a report for the ECC based systems. So let me show you some sample data for which I'm going to run this. So this is ECC usage.csv. So generally what we will have in it is for different timestamps and different systems, it will have logs for the CPU utilization, memory usage, disk IO, and active users. And using this data, it will estimate the usage of our provisioned infrastructure. And the second thing it will have is which will provide is the ECC cost CSV. So ECC cost CSV will provide us with the mapping for different components and the size of instances provisioned for it and the costing for those particular systems and their utilization percentages. So let's first get a CSV generated, a report generated using these CSVs. So for ECC, let's upload the ECC cost CSV. Then second thing we will do is usage CSV. Okay, so after that we will upload and generate report. Now it will take some time. It will do the processing to estimate the utilization over using current logs, and then it will call the GPT 3.5 model, 3.5 turbo model, to provide us with the recommendation, different sort of recommendation, which we will be able to see once our report gets generated. So currently it is generating the report for us. We'll wait for a few minutes for the report to get generated. Okay, so it is generating our report now. It has done the pre-processing for this CSV. Report is getting generated. Okay, so our report is ready. So it provides us with two options. Either we could download the PDF on our system with any sort of name we want to get, CC report. Okay, and we could save it over here. Or second option it provides is to view in the browser. So let's view the data in the browser. So it is the cloud optimization report. It is generated on 12th of June. It is the timestamp. It is using UTC based timestamps. Then it will show us the system types. So it is the overall system analysis. So currently our system's average CPU utilization is around 40% and average memory usage is around 11 GB. And there are 4 components, and out of these 4 components, 4 systems, 3 of them are underutilized. So these are detailed components data. So average CPU for app01 component, so and average memory and average disk IO and idle time. So this particular instance is idle, so no one is using it. So, and this is the DB related component. So average CPU utilization, memory, and average disk IO and idle time for this. So in this way, it will provide us with the proper utilization for different components, and then after that it will do the cost analysis for those. So for this particular instance, currently we have compute cost is this, storage cost and total cost, and similarly for all these components it will do the total cost estimate. It will calculate the total cost, and in the end it will tell us that our current total monthly cost is $1,835. So now it will provide us with the AI recommendations. So current first of all, it will give us with provide us with the current system analysis. So overall system health and utilization. So overall system health is relatively good, and average CPU memory utilization is 50%, and average utilization is around 39.8%. So key performance bottlenecks we have for current system is DPU one component is experiencing high CPU utilization, which is a potential bottleneck for our this infrastructure we have provisioned. And second one is AP02 is most underutilized component with only 17% average CPU. So cost efficiency, the total monthly cost it is telling us, and three out of four components are being underutilized in in our provisioned infrastructure. So second, it will provide us with AWS migration recommendations. So how can we optimize it to migrate to AWS cloud? So first one is it is telling us to consider moving to a smaller instance for app01 component. Instance type like T3 large or T3 medium based on utilization. So based on utilization, it will tell us to move to a smaller size instance. The second thing it is going to tell us is moving to for DB01, moving to a smaller instance type like R5X large or R5 large based on workload requirements. And for BW01, it is going to tell us to switch to a smaller instance type like M5 large or T3 medium, considering the low utilization. For app02, it will telling us that we could continue using T3 medium or move to a smaller instance like T3 small. So storage optimization, it is going to tell us that for storage requirements for each component, we can utilize EVS volume based on performance needs, the sort of performance we need. So it is giving us scaling recommendation to auto scale components like app01 and BW01, and it is telling us to vertically scale DB01 component. And other than that, it is providing us for cost optimization opportunities. So currently we have it is providing potential cost saving. So it is telling us to use AWS Cost Explorer to identify potential cost saving other than the one we have provided in this report. And it is telling us about right sizing opportunities. So we can continue savings over time. And fourth one it is telling is for it is providing us with implementation strategy. So it is telling us about migration approaches. We can plan a phased migration approach with less critical components like BW01 and app02, perform through testing before migrating critical components like DB01 and app01. And for risk mitigation steps, it is telling us to get the backup data and configurations stored before performing the migration. And for timeline consideration, it is telling us to create a detailed migration timeline considering the dependencies between components. And here are some additional consideration it provides, sort of security recommendation, monitoring performance, monitoring and maintenance suggestions. So it will provide us with different suggestions and optimization opportunities we can benefit from in our current infrastructure. And this one was for ECC based workloads. Now we can move back and try for legacy system. For legacy system, we will only have a usage CSV. So let's upload a usage CSV. Legacy usage CSV, it will be similar to the ECC usage CSV. It will only have system type legacy for it. So now let's upload and generate our report. So it is generating our report. So our report is ready. For it also we have those two options only, to download PDF and view in browser. Let's view it in browser. So it is also having similar sort of data like ECC1. So it also have those four components, and since the logs are similar, it is generating a similar kind of report for it. Although it don't have cost data in it, so there won't be the cost related section in the PDF. It will give us AI recommendation. It will tell us potential bottlenecks and those instance related data for it. Okay, this is all.